So, gentlemen, good evening. I I will mostly be rambling this time. There's gonna be no work. It is 2 in the morning or something like it. I want to elaborate slightly. That's a lie. This is gonna turn into a 50-minute video easily, but the moment I say elaborate, you know that you're in for a long ride if you're up for it and if you can tolerate me. But I want to elaborate on some of the ideas that I had regarding the situation and the solution with the damaged section of the ways. I plan on milling this damaged part of the ways completely flat to the bed, just flat, with a 90-degree transition into the what remains of the ways on both ends. Of course, having a radius cutter, an end mill with a radius, for example, a 6 fluter, no smaller than half inch, and with a nice corner radius just to give it a nice gentle transition. This is my idea that I will most likely be running with as a prototype solution, at least for now. Although once I do it, it's, as most prototypes turn out to be, turn into a long-term solution, a permanent one most likely. I will mill out the material, let's say some precisely 100 millimeters, because the damage in the ways is already some 8 centimeters or 7 centimeters, but there are some gashes into the remaining sections of the ways from the angle grinder, so all of that will be removed. As said, flat to the bed. I will then make 2 pieces that will replicate the geometry of the ways, expected geometry, expected as in I do not know the amount of wear that those surfaces which are now unavailable to me for measuring have had. So I'll have to make 2 pieces and guesstimate the amount of wear, make them transition nicely into what remains of the ways on one side of the bed towards the tailstock and into this one. That piece will be 0 clearance insert that will be as wide, or rather as long as the gap between the sections of the ways is. It's going to be machined and lapped into position just to fit as perfectly as possible. I want to do so because that will then return a lot of strength to the bed itself, because as things currently are and as they will be once I mill the ways, well, what little remains of the way material in that section out, the bed will have the tendency to concave itself in that section. Concaving itself will mean that the tips of the remaining ways are actually doing a pincer movement. That, with perfect replica material in steel or cast iron, it doesn't matter, being inserted in there and having no clearance will translate that pinching movement into compression of that material, which will simply not be happening. The amount of force required to actually compress 2 chunks of steel or cast iron of that size is ridiculous. There's absolutely no way that there's going to be any measurable loss of strength in the bed after that has been re-established. Those pieces will be glued in with some sort of a runny glue that will cure into a tough surface. I'm not sure if I will be using Mowgli's or some of the other machine restoration epoxies. To regenerate that, I have been rather to glue things in place. Most of it will be squeezed out of the space over here when the pieces are inserted, because they're supposed to have zero clearance, but still some slight chemical fastening cannot harm, and whatever does not get squeezed out will simply be filling out surface imperfections, which is not a bad thing. But that said, those two pieces being in place will allow me to plop over the rest of the ways. The first 4 inches and the last 4 inches I expect have essentially factory original geometry, no wear, because under the tailstock, no, under the chuck and under the tailstock there should be essentially no wear. But that is the current expectation. I expect to be somewhere in the middle of the ways, however slight, because this is a plain lathe that has no running carriage that traverses across the ways. It just has a plain cross slide that you unbolt from the rear, set up into position where you need from the rear, from below, and you fasten back the bolt, or rather the nut, from below, and clamp it into position like that. But there's bound to be some slightest amount of wear in the ways in the middle section, in the most active section of the lathe. That said, I'll take a piece of cast iron, because I currently have access to 2 pieces of cast iron that are as long as the whole bed, so I can pick and choose whichever one I want. They are equally thick, equally dimensioned in, well, all dimensions, so it doesn't matter which one I choose. But I can currently obtain those 2, and I cannot get a large enough piece of tool steel that I could plop over the whole bed and re-engineer the ways in it. So we're going with cast iron for now. With the ways pseudo restored over here, and with whatever small amount of wear is there in that section, excluding the 4 inches from both ends of the headstock and in the rear, this piece will essentially contact the ways perfectly in the first 4 inches and the last 4 inches. The rest over here will have some slight amount of clearance, essentially, because I could technically scrape it in as to match the wear pattern, and have this section match the wear over here, and match no wear over here and over here. I'll see how I will proceed, and how much effort things will require, but the idea is to essentially impart a negative geometry of the ways into a piece of cast iron, make the piece wholly match the surfaces of the ways perfectly, of the ways and of the bed itself. Also have an integral key milled by removing decking, essentially 2 gullies, and leaving a central ridge in that cast iron that will reduce it by some, I don't know, a centimeter. Let's say that a key could be tall, because it's a decent positive bit of fixturing geometry and locating geometry, along with the ways themselves, which should technically fit much more precisely than the key. The key is just, you could even consider it as a strengthening rib that's going to pass along the whole bed. I have actually been considering making the key much deeper, or rather taller, over here in this central section of the bed, because this tailstock section has a true T-slot, which extends into just a pass-through slot through the bed, and becomes another true T-slot over here in the headstock section of the bed. Each foot has a true T-slot, and the center doesn't have a true T-slot, it has a pass-through slot, but you get the point. With the geometry machined in, the piece would be just plopped over the ways. Everything would be, of course, degreased and bathed in acetone for a week, and cleaned of any oil and contamination. Everything would be covered in a layer. Both surfaces, the negatives and the positives, would be covered in a layer of low viscosity binding agent, like as said, Moglis or something like that. And the piece would be plopped over the ways. The clearance is over here, the radial clearance that the ways into the bed would have, and a slight, how would you call it, beveled cut that would be imparted into those two pieces that would be restoring the ways, just interference blocks essentially, to prevent the bed from clamping. You get the point. I've already gone through them. Those small amounts of radial clearance in there would also be filled with the same binding agent, and this section would be plopped over the bed and compressed with a large enough weight. I don't really have a large enough weight to compress this whole section at once, but I have a large enough weight just over here underneath. That is some 55 kilos or something of nicely machined steel that can rest atop most of the bed, and I have a smaller piece that can come over here. I will not be putting the smaller piece over here just because of potential lesser rigidity of the bed in here, and having a large piece contact this whole weakened section of the bed. It's not weakened, but it's not as strong as the section that has the feet, the sections with the feet. You get my point. There's some small amount of rigidity loss in not having this be a whole massive section, but being just a bridge essentially between 2 feet. Having a large enough piece that spans this whole section at once should technically result in a much more even distribution of the forces, as there is not just a small piece over here that has some 20 kilos. That piece is going to be over the foot over here, but that's gonna be 75 kilos. Compressing that, I might even add more weight, more mass to it. I have quite some nice pieces that could act as weights in addition to those. So that's going to naturally squeeze the chemical binder into all the crevices and all the surface imperfections. The bed itself has some slightest amount of porosity, how would you call it? Also has some small amount of porosity in the box section in the rear part of it, but nothing really important, nor something that should be really seen to, but while I'm at it, I might as well add it. Once the binding agent cures and generates a nice chemically stable bond and a essentially completely perfect contact between the two pieces, the final machining can begin, and I can drill in a whole bunch of holes for the custom turned bolts. As you can see, they're gonna have a cap head screw, regular bolt head design, but they're gonna have a precise cylindrical section that is going to act as a locating pin that's gonna pass through the material for the ways, replica material, and is going to enter into the ways and into the bit of the meat of the bed, and it's going to fasten into the bed itself. Of course, it's gonna start fastening in this box section, rather than into the bed, because this is some almost 1 whole inch of material, so it doesn't have to go all the way through what's gonna be an inch of material atop it and into an inch over here. That would make a huge fastener that would be an overkill and would actually be weaker just due to the length. A shorter precision section and the shorter thread would actually be more rigid material wise. So yeah, there's that, and Yeah, I will mostly just inspect the bed for where I will gently maybe scrape it or lap it to make it perfectly level along all the flat sections of the bed. And I'll remove any high spots from the ways if anything is dinged as well in the bed, just to be able to make this other surface a perfect fit with the ways. I'm not sure if I will be making the peak and the valley of the negative of the V-way a perfect matching fit. I might leave it with a small amount of clearance just because you get the point. The V-way, when everything is going to be tightened, that's why the bolts are going to be running zigzag, as you can see, rather than through the center of the V, which would be the ideal drilling scenario, because you could just drill flat through the material against another flat, and the drill would have no tendency to deflect. The material here is going to have a perfect surface-to-surface contact, but the ways themselves could be slightly harder than this material, or this material could be slightly harder than the ways, which means that the drill, once it enters this material or tries to enter it, if it is harder, it's going to be more likely to deflect at some weird slight angle, or rather make a curving bend, which is suboptimal. But this would be much better. But again, unless there is absolutely perfect contact within between the flats, the V, and the peak, and the peaks, and back to the flats, any tension applied to this, to the top, even though the bolt head would be compressing outside of the V and fighting any deflection, the V could try to essentially pry this section of the ways upwards to deform it, and having the bolts in a zigzag along the V is going to actually exert much more pressure in this section of the way, which is going to clamp it down quite nicely and negate any potential deformation of the material that the V could try to induce in this already weakened section by the fact that it has a negative geometry machined into it. That being said, that kind of brings us to the second idea, that is the ultimate compromise in this situation. It mostly follows the same recipe. The negative geometry is machined into the last and first 4 inches of the material, but this central section is left completely solid. The ways are not machined just where the damage is, but until the last 4 inches and the first 4 inches, everything except those is completely removed. The solid material section is machined precisely to be a perfect gauge block stack up between those 2 sections of the ways, and everything else goes naturally, as was just explained. Mogulising, threading, everything still applies. That would be almost the ideal situation, because then this material would be extremely robust over here. It would still rely on the factory original, at least speculated state of the ways beneath the chuck and beneath what is supposed to be tailstock, but this lathe doesn't even have a tailstock, so you get the point. That would be the ideal compromise and solution over here, because the ways would provide immense rigidity in regards to alignment of this piece in relation to the headstock, because there is absolutely no way, if the machining is precise enough and if the fit up is perfect, that the material could ever hope to move even 1/50th of a millionth of an inch either to the left or to the right. It would potentially hope to slide backwards, but with the amount of precision locating pins that's going to be distributed along the whole length of the bed, there's also absolutely no way of that happening. It would have to shear or at least slightly deform no less than 40 fasteners that are in hardened steel. That's simply not going to happen, nor could it ever. Those are the amounts of force that would essentially break the whole lathe in half sooner than you would achieve that. But that is the potential solution, but that would require some ridiculous precision in machining of that stack up, as that cannot really be lapped by hand as well as you can if you take a piece of material that you just lap on a plate and that you try to fit again and again in relation to the small section that is removed until it fits perfectly, and you do the same with the V and the boxway. But yeah, that's that. Everything else I said remains the same. And final and essentially worst solution is just milling the whole bed flat, all of it, and making a piece. I would then prefer tool steel, and quite a nice piece of tool steel at that, that would have a central key, relatively tall, relatively short in this section, as said, because this has a true T-slot that has a bottom and that has have a T-nut running in it to actually be of any use. So a relatively short integral key in tool steel milled to stick into this, and a large section of the key protruding. It's not a key, it's a central rib, just a strengthening piece that would pass into the section of the bed. And again, I'm not sure even if I said it, I'm planning on machining. This is going to apply to any design. However I approach this, this piece is going to be made a huge T-nut that is going to be inserted into this lower reinforced section of the bed that is used to back up the nut that you use to fasten the plain cross slide wherever in this section of the bed where the reinforced slot is depicted. You can see that the foot does not end at the end of the bed on the lathe itself, but you get the point. In this section of the foot is where the slot ends, and true T-slot is in here as well as under the headstock. That chunk would be made out of some 3 or 4 centimeters large material. Large, I'm sorry, I'm retarded, tall, and it would also have a nice chunky section of the T over here that would just be inserted into here and would fasten into this upper section, merely to provide additional support to the bed itself and to strengthen it a bit more. Now one could theoretically make the key section, the extended T, the I section of the T, of this T-nut and this central rib key again match up perfectly in the middle of the lathe bed, and have those two pieces compressed by well, a whole bunch of fasteners that would be going through them. But that would again require some astronomical levels of precision to perfectly match that along the whole length of the, well, central cavity of the bed. Just have a perfect compression fit that does not actually try to bulge the bed out by compressing it. You get the point. That is a possibility, but that would be ideally done in tool steel, and everything would then just sit and be located by that central key. The flats of the bed would match the flat perfect geometry of the tool steel piece that would have the dovetail ways imparted in the sides, and voila, you would regenerate the ways in that manner. Also a whole bunch of bolts that would fasten the shit out of it to the bed, just even more so because it doesn't have the ways to actually ensure the alignment. But yeah, all of that is ultimately a compromise, because whatever I do, the headstock remains at the height that it is, and whatever I do is going to end up taller than the original ways, because I cannot make something as short as they are. They can be short because they're integral to the bed, but whatever I apply cannot be as short as they are. It simply must be taller just to have rigidity enough to actually be even at their level, or to transcend their level and be more rigid. But yeah, all of that means that I'm losing on maximal turning diameter, which is the exact same reason and the source of the problem that I'm currently trying to solve, because whichever savage beast cut into the ways of the lathe did so at the exact place where you would need maximal diameter for turning increased. So somebody tried to turn something that did not fit the confines of the lathe, the work envelope, and they just sliced into the ways. Just nice. But yeah, I don't lament that loss too much, but at the same time there are some things that I could do. The cast iron part, as I said, that I will be using, as you can see, is depicted here, running from the headstock to the end of the bed. I could technically not cut that piece at all and have it run from one end of the bed to the other and have it lift off the headstock. I could impart the same waist geometry in this section of it over here, because as I said, the stock that I'm going to be using is some 2 centimeters taller than the final waist section will actually be once everything is fully machined and lapped into geometry. So I could technically impart a bit of this geometry back over here in the rear and have the ways run all along the original ways, again restoring that weakened section just to negate any potential compression, or rather negate any potential deformation by giving in a piece that would be acting and resisting with compression in that small section. But that's a moronic thing, because if I do that, then the headstock is going to be propped off of the bed and is going to have a huge gap between it and the rest of the bed. You can see that there is some slight, I'm sorry, I don't really have anything that I can use to show it, but there you go. You can see that the headstock has a nice clearance to the rest of the bed, and that section would not be imparted by the material, so I would have a nice huge hole over here that would just look ridiculously stupid. So that doesn't fly with me either, that would just look retarded. But having it butt up against the headstock and have the headstock butt up against it, maybe even fasten the headstock into that section, I could potentially insert the same system of cam that the headstock uses, an eccentric cam to tighten the bolt in this T section of the, well, you get the point. Or you don't, but you'll get it at some point when I'll be showing that. I have already showed the headstock from below and its clamping mechanism, so if you have seen it, you get what I mean. Impart such a system in here that would clamp the headstock from this section, would pull the headstock toward it, so I don't have to machine much in the headstock. I would just have to impart 2 threaded bores in the face of the headstock, which isn't really a problem. I could even technically use the insert that is the eccentric cam for this section over here, and essentially change it from an Allen bolt, Allen wrench fit over here, have it a threaded fit, and have that threaded fit be actuated and clamp the headstock to the bed as it is being clamped by this section. Essentially have practically a gear mesh, a powertrain that would fasten both the headstock towards this and onto the bed simultaneously. But that's a whole lot of work for essentially a marginal, well, it's not a marginal improvement. It would offer quite some nice rigidity in that system, as it would bind the headstock and ways and pull them together, ensuring even more tension in that section of the machining envelope and retaining everything even more viciously in position. But yeah, I'll pretty much stop rambling. That is what I have in mind for now. I hope that I have explained everything nicely and as well as possible. I'm not sure, I might have missed something. I'll see. Anyways, I just wanted to update you slightly on the thought process regarding this situation and solutions that I have been thinking of. As I said, or if I said, I'm not sure, it's all a variation on the same idea. All of it implies a large T-nut in the bottom, this piece that would slot into this reinforced section. All of it implies a central key. It's not a key, as I said, because only in the case of a tool steel where everything would be flat ground and the key would be the only locating and aligning feature, would this slot have to be perfectly surface grinder flat ground to have perfect dimension along the whole length, and the key would have to fit it bloody perfectly just to actually allow for some proper locating and retention in regards to angular alignment. But most of the features are generally being translated and are coming with whichever system I choose to actually put into practice. But as I said, I think I will be making two pieces individual that will be slotted over here in the 10 centimeters generated gaps with nice radial transitions from the flat of the bed into the flat of the ways with slight undercuts, moglist or thread locked into place. This is going to be plopped over, weights, yada yada, machined holes with reamed fits and everything fastened, pretty much done. Another long T-nut that's going to be inserted over here, as you can see, just to allow this section to be even further bolted down the middle. That you can see, this is the bird's eye view of this section of the bed, essentially. You can see that it is crossed over here, supposed to have a slight hint of a shadow that is supposed to be the lower surface, this channel. This section, as I said, has a through slot. But yeah, I'll try to shut up. I hope that I have not bored you to death, and that this was relatively short. Let me see. Oh, over half an hour. Quite nice. But yeah, anyway, that will do it for this evening. These were just some of my thoughts. I will not even go into how to potentially run the headstock, because of the original design that implied the belt going through the foot over here into the cabinet, and the motor being in the stand in the cabinet below it. But we'll get to that in some other video. This is currently all that fits the scope and the subject of this video, which is the bedway or the ways solution. So until the next installment, I wish you all the best, and I hope that you enjoyed. Until then, see ya. Bye bye.